Now getting into some of the chemistry involved with organic molecules. First of all, some properties, okay? So alkanes, right? Straight chain alkanes, non-polar. First of all, carbon and hydrogen have very similar electronegativities, so really that bond is not considered polar anyway. And it is completely symmetrical. Everything is spread out perfectly, very non-polar, which means it is insoluble in water. You cannot get alkanes to mix with water. They also have very low density. They're very unreactive, except for combustion. That doesn't count. They don't react with much else other than combusting, but they are very highly combustible, right? Any of these carbons and hydrogens burn in oxygen, you get carbon dioxide and water, very easy. So unreactive except for combustion. So if we burn them in air, we produce energy, of course, and that's mainly what we use hydrocarbons for. We can also do a reaction called halogenation. As the name implies, that would mean putting a halogen onto an alkane. Okay, we know how to name these, right? This guy here, we could name it, but how do we do it? We start with an alkane, we add whatever halogen it is we want, and what happens is one of these chlorines switches places with hydrogen. So now I have a chlorine on it, and I end up with an HCl. So the chlorine kind of switches places. That's called halogenation. So these are the two reactions that we would be doing with alkanes, combustion or halogenation. Okay. Alkene reactions, we've got a couple of different options. And so anytime I present you with these reactions, we have to figure out what our products are going to be. So we can do hydrogenation, halogenation, or hydration. Hydrogenation, as the name implies, means I'm adding hydrogen, okay? And if you add hydrogen, H2, to an alkene, it turns that alkene into an alkane. So instead of having the double bond, you're breaking the double bond and adding those two hydrogens on. I could also do halogenation. So instead of adding H2, I could add a halogen, so Cl2s. And what would happen is those chlorines would break the double bond and go on there, just like a hydrogen would. But now I have two chlorines to the carbons of that double bond. So break the double bond and the chlorines go on. So this is hydrogenation, this is halogenation. I can also do hydration, as the name implies. I am adding a water. So what that does is it, again, breaks the double bond. And on one, I will have a hydrogen. And on the other one, I will have an OH. Okay. Now, which goes on which? This is a rule that kind of tells me what's going to go where. This is Markovnikov's rule. If I add something that has a hydrogen and something else, okay, so it could be H, let's call X is for the halogen. So I could add HCl or HF, or I could add HOH, which is water, right? The H sticks to the carbon that has the most hydrogens on it. Okay, so I'm going to show you what that means here. The other thing goes on the other carbon. So if I have this molecule here, this is 1, 2, 3, 4, this is butene. Okay, I'm adding HBr. So the H is going to go on to one of these carbons, and the bromine is going to go on to the other. So which is which? The H goes on to the carbon that has the most H's. Now what I did down here is I wrote out this butene molecule. So this carbon has 2 H's and this carbon has 1 H. So the H goes here, that leaves the bromine to go here. Same thing happens with water. If I was adding HOH, the H would go here, the OH would go here. And so this ends up being my new molecule. So that is Markovnikov's rule for addition. Anytime you're adding something to an alkene, it's going to add on to where that double bond was. It's going to break that double bond and add those things on. Markovnikov's rule tells you what goes where. Okay, so some practice. Example number 8. Give the products of the addition reaction. So these are called addition. I am adding something on. Assume that Markovnikov's rule applies where necessary. So I'm adding just an H2. That's going to break that double bond and put a carbon on each. So I'm going to have CH3, single bond, CH2, CH3. That's my new product. I have this molecule, I'm adding H2O, which is really just an HOH. Now I put the H on this carbon because H likes to go with the other H's, and the OH on this carbon. So now it looks like this. I added an H here and an OH here. This one I'm adding Br2, so a bromine would just add to each. And same thing applies for cyclos. I'm adding HOH. Well, an H is going to go on one and an OH is going to go on the other. It doesn't matter how you would draw it in that case.